Okay, so review from yesterday. If you remember with the electron configuration, right, the first coefficient that is listed is the row number. So whatever row the element is in that we are looking for or going past or reading. That is also known, remember, as the shell number or the number of rings, right? So if you're drawing the Bohr model from yesterday, I told you each energy level is another ring, okay, around that Bohr model. So possibilities, remember, are up to 7, since there are 7 rows down on the periodic table. This right here, this letter, there's 4 options, S, P, D, and F. Remember that. 4 different options, just because there are 4 subshells. So I have that on the board. I finally finished it. It's not the greatest because I have not taken an art class ever, but there you go, S, P, D, and F, and my color-coded chart there. And then this last superscript at the very end is how many valence electrons it has. Okay, so, you know, for this one, 1s1, we are talking about hydrogen. Okay, hydrogen is in the first row. It is only located in the s orbital block, right? So the s block. Oops, sorry there. And if I go back, and of course it has 1 valence electron, so it has a superscript of 1. So this is also known as the group number or number of valence electrons. Depending on which subshell it's in and which element it is, there is a possibility of how many valence electrons. Now remember, I told you with the D and the F yesterday, the D and the F subshell depends on which element it is, okay? How many superscripts, right? The number that is in the superscript here. Okay, so what I do is kind of every time, and I kind of put this back in here, every time I jump over, I start back. The only time I do not do that is with hydrogen and helium. So if you remember, right, hydrogen and helium are just the 1s block. So 1s1 and then 1s2. Mainly because this has 1 valence electron. Since this only has 2 electrons, this has 2 valence electrons. That's kind of a exclusion there. It's off because everything else has 8 down the row, but it is acting as a non-metal. So then when I come back here, I'm back to the s block, right? And so if you notice, every time I jump to a different block, I start over on my valence electrons, right? So if I jump from the S block here to the P block here, my valence electrons or my superscript starts back at 1. Okay, if you remember that from yesterday. And so then I count over how many, right? So if I'm talking about neon, I'm counting how many over is neon in my P block. And so that is the number of valence electrons, okay? And so in this case, since it's the 6th one over, okay, I'm going to put 6. And then if I add the 2, okay, then we're looking at, that's the row 2. So that would be 2s2. And then, of course, I'm still in row 2, so 2p, and I'm 6 over, so 6. So that's kind of what we're looking at. Same thing with D. Once I started this D block here, if it helps looking at that one, right, my transitions are purple. I tried to keep it purple here because of there. Okay, purple, purple. That is my D block. And so when we hit the D block, yet again, my superscripts are starting back at 1. But if you remember, the D block can hold up to 10 electrons, and if I count over, there is 10. From scandium to zinc, there are 10 elements, and so that just makes sense. Every element over is another superscript. So +1, +1, +1, +1, +1. Same thing with the F block. Once I get to this F block, remember this is like my flower orbitals, right? They look like little flowers. I start back at 1 again, 1 through 14. Okay, so I can have up to 14 if I'm talking about lucidium here. And so at that point, I start back at 1 every time for my superscripts. And we're looking at that, right? So based on where I'm at in the periodic table, that superscript can start back at 1. So remember, the S can hold 2 electrons, the P block can hold 6 electrons, the D block can hold 10 electrons, and the F block can hold 14 electrons. Okay. And so we get to this idea, right? Total electrons is the atomic number. Remember I told you yesterday when we were doing it together that I can always double check what I put down because I can count those superscripts all the way up and it should equal the atomic number. And of course, you fill those energy levels until you run out, and then that superscript is the electrons are in each level. So here you can see hydrogen, like I talked about, 1s1, helium 1s2, lithium 1s2, 2s1. Now somebody yesterday had a question, why don't I put 1s1 and then 1s2? Right, because the number 2 includes 1s1 and 1s2. So I don't have to double state those. Okay, so in this case I just put 1s2, and that includes both hydrogen and helium. They're included together. Okay, so then we get to beryllium. I'm including the hydrogen, helium here, and then I'm also counting the lithium in that, right? Lithium is 2s1, and then beryllium would be 2s2. Okay, it is in the second row in the s block, and it is 2 electrons over, right? 2 elements over, or the second one. And then I can count my superscripts. 2 plus 2, that equals 4, if you remember that from yesterday. Okay. Okay, so this is what we did yesterday in class, right? Do I need to go over any more or back over these? Yes, no? I'm seeing no's. I'm seeing a lot of no's. Okay, so I'm going to move on then. Okay, so now we get to the D and the F. This is what I'm looking at. Okay, the D and the F blocks. Like I said, remember that when I'm looking at the D and the F, okay, really the F should be here. If you see in the periodic table, there's 2 blocks. It's literally lanthanide and actinide. They should be placed in here, but there's not enough room, so they dropped them down, okay? So when we do these, right, you got to look over here. This says 4 through 7 energy levels. But these are actually, since they're semiconductors, right, semiconductors have less energy. And so in this case, it's almost as if they are bumped up 1 for energy level. Okay, so in this case, I'm not counting this as a 4. This first row, I'm going to count as energy level 3. It should be bumped up, okay, because it is a semiconductor. They do not have as much energy. They do not require as much energy. So you just have to remember that this is almost as if this whole block here, the the D block and the F block, gets bumped up 1 energy level or 1 row. Okay, so then when you're looking here, so even though it's energy level 4, we count it as an energy level 3 here, and then it gets bumped up 1. Even though it's in row 5, it's considered energy level 4, energy level 6. Okay, they just do not have near as much energy as an other metal, right? So they do not have as much energy as your alkali metals, which is group 1, or your alkali earth metals, which are group 2. They do not have near as much energy, okay, or these other metals over here. So that's what we're looking at when we're writing these. You just have to remember that they're bumped up. Bumped up an energy level. Same thing down here. The lanthanides actually get bumped up 2 energy levels. So if you notice, this starts with 4F, and then this one down here, right? Same thing, bumped up 2 energy levels, so it is a 5F. These are very low energy. Okay, it just takes just a little bit of energy to get them excited. It does not take much energy at all. Okay, which is why some of these are extremely hazardous, right? It does not take much to get them very excited. So in this case, right, this lanthanide is 4F, and then this row, even though it's the 7th energy level here, it is considered the 5F. So it's in row 5 technically. Okay, so we have to keep that in mind, and I know that's tricky. I understand that. That's kind of where practice is going to help you, right? The more you do this, the more practice you get, the more this will help out. And so for here, we're just looking at it getting bumped up in 1 energy level in the D, but right here, okay, we've got to look at these also being bumped up in energy level also. So if these are also bumped up, that puts these 6, right, this lanthanide in the 4F, and then the actinides are put in 5F, right? So it's almost as if they're just shifted 1 up. Does everybody see that, kind of as if you were to shift it 1 up? Okay. So we've got that bump there. Okay. So when I'm writing these, right now I get to the D orbitals, okay, and in between, right, we got to go by that energy level and how we're going to progress through them. Okay, so I'm going to walk you through this one. So copper, Where do I start? Remember, I got to start clear back at hydrogen, right? It's a long process. So I start with energy level 1, so 1s. And remember, I'm counting hydrogen and helium, so I put 2. Right? So that knocks out hydrogen and helium. If you want to put a line, right, you can put a line through hydrogen and helium. I cross those out. I jump down. Now I'm at lithium and beryllium. Okay? So we are in row 2, right? So 2s2. So I can put a line through lithium, beryllium. I've crossed those out. I jump over to my p block. So remember, my superscripts start back at 1. They can hold up to 6 because there are 6 elements across there. Boron through neon. So if you remember, that's my p block. I am still in row 2. So I'm at 2 and I'm in the p block. How many over do I have to count? Well, boron through neon, right? So that's 2p6. I can cross those out. I come back down to energy level 3. So I am in row 3. I have to account for sodium and magnesium. So that is S2 because those are both in the S block there. Now I jump over to aluminum, right? If you're following along with me, I'm right here. Aluminum through argon. I don't have those elements, so I have to account for those. So that's back in the P block. So row 3, P block, I go through all those, so that is 6. I cross those out. I'm back down to energy level 4 now. Right, row 4 or period 4. I have to go through potassium and calcium, so that is S2. Those can cross out. And remember, I told you with the transition metals, it bumps back up a row. So I have 3D. And how many into my D block am I? 1, 2, 3, 4, 5, 6, 7, 8, 9. Thank you. 9. Then, to remember to double check these, okay, to double check, what's the atomic number there? Atomic number is 29. Do my superscripts add up to 29? Well, I double check, right? So 2 plus 2 is 4, 6 is 10, I have 12, 12 plus 6 is 18, 19, 20, so that gets us to 20 plus 9, so 29. So I've just double checked my superscripts account for every electron there, so that is equal to 29, and we're good to go. I am done with that electron configuration. Okay? All right, so now we are on to, what is that, bromine? We got the arrow on it. There we go. Bromine. Where do we start? Back at hydrogen, right? We start back at hydrogen, so 1s2. 2s2. 2p6. 3s2. 3p6, right? You see, I'm crossing out aluminum from argon. I'm back to 4s2. I just crossed out potassium and calcium. 3d. How many do I go through the 3ds? All 10, right? So I go through all 10 because now I'm going through zinc. And then remember, the P block stays as it is, so I jump back up to row 4. 4p, and I'm 5 over. So then again, I double check. What's the atomic number there? 35. So I check with the atomic number, 35. Then I add my superscripts. Do they add up to 35? Yes, they do. They equal 35, and that means I am correct. Okay? Like I said, it's tricky here, and I understand that because you're like, why would we go from 4 to 3 to 4, right? And it's all because that whole D block gets shifted up 1 energy level, right? So, because these require less energy to get excited, okay? It does not take much to excite those electrons. And so since they take less energy, they are bumped up 1 energy level, okay? So you just got to remember, okay, I'm in row 4, but it bumps up an energy level, and then the P block, I'm on the same row. So it goes from 4s2 to 3d10 to 4p5. Okay, now we're at rubidium. You see rubidium there, it is in energy level 5, row 5, period 5. Okay, so I'm starting back. 1s2, 2s2, 2p6, 3s2, 3p6, where am I at? 4s2, 3d10. Now remember, this time I'm at 4p, but I go all the way through the 4p's now, so 4p6, and then I'm at 5s1. Now yet again, I have 37 for the atomic number. Do I double count that? Do I have 37? Yes, the superscripts here add up to 37, because here is 30, and then you've got 6 plus 1, that gives me 37. Remember to add your superscripts, okay? So keeping that in mind. All right. I know we went through that really fast, but remember, it's like building blocks. You have to account for what you've already read, okay? You have to start back. You have to account for every single electron that is in that atom, okay? Because remember, the atoms build off of each other, because every time there's a new element, they're just adding a proton. Add another proton. And remember, every time you add a proton, you have to add an electron, because they're a neutral atom, okay? So you're just adding and adding and adding. Because remember, I told you I would never ask you to do number 118, right? Because if I had you do 118, whew, might take us a while.
No, we got it.
We could do it, but it would take us probably at least 10 minutes probably to do, I'd say. I don't know, I get pretty quick out.
10 minutes?
Yeah, I'd say.
I got done in 5.
Okay.
Can I prove it?
Not right now.
Your board's a little bit delayed.
I know. Okay. All right, moving on. Let's see. I don't want to do that yet. I need a blank slide. Okay. So now, that stuff that I just passed, I'm going to cover tomorrow, okay? So don't think I'm not going to cover it. I won't cover it tomorrow. I want to do one in the F block. Okay, so let's do one in the F block.
Gadolinium. Gadolinium.
All right, so GD. Oops.
Is
Sorry.
that how you say that? Gadolinium?
I've heard it 2 different ways, so either way you pronounce it's fine. All right, GD. Okay. So here we go. We're starting back at hydrogen, right? So we have 1s2, 2s2. I'm going through row 2, so 2p6, down to row 3, 3s2, moving on to 3p6. Now I'm into row 4, 4s2. That puts me through calcium. Remember, it jumps up in energy level, so I'm at 3d10, 4p6, because that puts me through krypton. I'm now in the 5s, so 5s2. So that puts me through strontium. Okay. So now we're at 4d. Yep. So 4d10. And then you got it, 5p6, 6s. 6s2 puts me through barium. And now we have to jump down to energy level 4, F. How many over are we?
8.
5, 6, 7, 8. We are 8 over, 4F8. Then I count. What's my atomic number there? 64. Do I equal 64?
36.
This should be 36. 38. 48.
54.
55. 64. There you go. Okay? So it's a way to double check. Do I have 64 electrons accounted for? Yes, I do. Moving on.
All right, well, now that we're here, liver morning.
Okay? You want to do number 118?
60,
160.
Yeah,
Okay.
160.
All right.
We got it.
We got it. Okay.
And you're on the clock.
Hold on. Anybody copying that down? No? Okay. Oh man, I tried. It's not wanting to work today. Okay, so let's do, what'd you say, 116, which is the memoriam. Okay. All right.
1s2.
So we got this. Okay. I'm going to start down here. 1s2.
2s2.
2s2.
2p6.
2p6.
3s2.
You got it?
3p6. 4s2. 3p10. 4p6. 5s2. Then 4d10. Oh man, I messed up. 4p6. 5p6.
We're at 5.
6s2. Oh.
Right,
so
6s2.
this one would be 5.
It'd be 4.
4f. 14. Then we jump back to 5d10.
Sheesh.
All right, and then we're at 6p6. And then we do, 7.
S2. Oh man, we had it under 5 minutes.
Oh, come on.
Whoa, look out.
7s2. All right, then we're at 5f14. Then we are on to 6d10. And then 7p. 1, 2, 3,
That's what had me.
1,
messed
2,
up,
3,
sticking
4.
out the Lanthanides back
4. Woo! Done. What's my time?
Like 2 minutes.
You didn't check it.
Oh, I haven't checked it.
Check it.
Touche.
2, 4,
Okay.
6,
116. Okay. So we've got
12, 18, 20,
48,
30, 36, 38, 23.
38, 54.
Oh yeah, you're good.
I am good. 116. Whew.
3 minutes.
What was that? 2 minutes? Something like that? All right, put me in, coach. I'm ready.
All right, well, if you're
I will win
ready.
the money. Okay?
If you're ready.
Okay, so that is literally all, in this case, we just did 116 electrons are accounted for in one atom. If I wanted to draw the Bohr model, then we draw the Bohr model. It would have how many rings? Should have 7 rings, right? Should I draw it? Let's do it. We got time. So we got 116 protons. How many neutrons? Oh, what is that number? 293?
294.
I see it. They changed it. They
changed
updated it. It's now 290,
293.
293. This is the old one, that's the new one. So 293 minus 116. So 6. What is that? 8. And then 8 is 7. 1. So we have 178 neutrons. And then I have 7 circles. 1,
Wait a minute, I don't think it's 8.
2. 13.
Wait, that's 7. You got 177.
Perfect, thanks. I was 1 off. 1, 2, 3. Oops, I'm gonna have to do 4, 5, 6, 7. Woo!
Yikes.
All right, remember the first one can only hold 2. So let's make those a different color. 2. The second one, remember my P block can hold 6. 1, 2, 4, 5, 6. The second one can hold, well, let's do it by rings in that case. So then we have 1, 2, 3, 4, 6, and we've got another one which is row 5, 3, 4, 5, 6, 8, 9, 10, so forth, so on. The next row can hold 14, and so at that point you're going to have 116 electrons on those rings. Woo! Okay. I am stopping for today so you can work on your homework.